Hello everyone, welcome to another video with Rahul. This is the sixth video on the series AWS Solution Architect Professional Exam Tips. And this will focus on an important topic, hybrid connectivity and multiple VPC network. So these are some of the topics that we've already covered, and this is the sixth one that we'll cover in this video. So this topic has two important subtopics. One is the hybrid connectivity. How do you establish connectivity between an on-premise customer data center and Amazon VPCs? And the second one focuses on Route 53. So now let's look at hybrid connectivity options that a customer needs to choose from. So this syllabus I have got from the exam guide. So the three things we need to know before we get into the more important ones at a high level is what is AWS Managed VPN, AWS VPN CloudHub, and Software VPN. So now first let's look at what is AWS Managed VPN. So it's pretty straightforward. You have the customer data center and you install the customer gateway on the customer data center, and on the Amazon side for your VPC you have the virtual private gateway, which allows you to set up a IPsec VPN tunnel between the two. So all the components on the AWS side are managed by AWS, which is primarily the virtual private gateway, and that's why it's called as AWS Managed VPN. So this is pretty straight. Now let's look at what is AWS VPN CloudHub. So what AWS VPN CloudHub does is it's basically if you're looking at a potentially low cost hub and spoke model for primary or backup connectivity between your remote offices, then this is the option you should choose. So what it does is, say you have multiple remote sites and represented by 3 blocks here. You install a customer gateway on each of them, and on your Amazon VPC side you have the virtual private gateway, which acts as a hub, and all of these customer site offices or data centers act as a spoke. So if you have to establish connectivity with the Amazon VPC or between these customer data centers or offices, then you can use virtual private gateway and this Amazon VPC as the hub. And then you have the software side-to-side VPN. So in this scenario, what you do is you have the customer data center, you have the customer VPN installation on the customer side, and then on the Amazon side you do not have the virtual private gateway. So what you will do is you'll use the internet gateway which routes the traffic to your VPC, and then you route that traffic to a particular subnet where you have AWS partner VPN appliance installed on the EC2 software. So that's how you can establish the connectivity. So the only difference here is that you by yourself are managing both ends of the software on the Amazon VPC as well as your customer data center. So this could be due to compliance, or you might have already some contracts that are running which you want to use. I'll provide the link of this site in the description. Now the second super important thing that you need to know is on hybrid connectivity using AWS Direct Connect. Direct Connect is the most important service that you need to know if you are trying to establish a hybrid architecture between your on-premise data center and AWS cloud. You can also use the VPN, but that's only if you have a very few workloads or you're just trying to do some POCs. Okay, now let's look at what are the options we have from AWS Direct Connect perspective to establish the hybrid connectivity. So if you look at this diagram, I think it's not shown the customer data center, but let's just assume you have a customer data center, and what the customer data center will do is you will have whichever region you are trying to establish that connectivity with AWS, you will have multiple AWS partner locations, basically partner data centers, which help you establish the connectivity with AWS. You cannot directly establish the connectivity with AWS, so you have to go through this partner network. So now let's assume you have this partner network here. The partner network will provide you with a customer router, and you have to establish LAN connectivity between your customer data center and this customer partner router. So once you establish this, then what the partner will do is it will also have a AWS device on their side, and it will establish connectivity between AWS device and the customer router. So once this has been established, then you have four options. So if you look at the left side where it says private WIFs to VGW, option 1. So what will you do in this case is you will establish connectivity with the Amazon VPCs. And on the Amazon VPC side you will have the virtual private gateway, and you will have the private WIF which will establish that connectivity. So it's a great, you can connect multiple VPCs using this private WIF to your on-premise data center, but there are some limitations, and the limitations are that you cannot have more than 50 VPCs connected through this private WIF to your on-premise data center. It's also region specific. Whichever region you have the partner location, that is the only region to which you can establish the connectivity. So while it's good, but it's not very widely used. Now let's look at the second option. The second option is private WIF to direct connect gateway. So in this option, what you do is you using the direct connect gateway, you have the private WIF which allows you to connect between your data center to the Amazon VPCs. On the Amazon VPC side, you have the private gateway, virtual private gateway on each of the Amazon VPCs connects to your data center via the direct connect gateway using the private WIF. So this is a good solution. It is also across regions, but the only limitation with this is that you cannot have more than 10 VPCs that can be connected to your data center. So while it is across regions, there's a limitation of how many number of VPCs that you can connect. So again, there's a limitation because most large organizations would have 50s and hundreds of VPCs. Now the third option that you have is using the transit WIF. So what this transit WIF does is you establish the connectivity of your data center using the direct connect gateway, which uses the transit WIF to connect to the transit gateway which is in your network account, and then each VPC is connected to this transit gateway using the transit gateway attachment. So in each VPC that you are trying to connect to transit gateway, you have a VPC attachment which connects to transit gateway, which connects to a direct connect gateway using the transit WIF, and then you can establish the connectivity to your data center. So one limitation here is that this transit gateway is region specific, but the option that AWS provides you is that you can do a pairing between various transit gateways to establish a cross connection between various regions if you have VPCs in multiple regions. Fourth option that you have is if there are certain services which you want to access using the public IPs, then you can establish a VPN connection over the public WIF and then connect to these VPCs. So these are the four options that you have from connectivity perspective, direct connect. So you need to remember all these because and the limitation at a high level, because the questions, they could ask you, okay, you have multi-region VPCs, how do you establish hybrid connectivity? So you could think of two options, right? You could have private WIF with direct connect gateway, or you could have transit WIF. So if it wants a cost-effective solution. So if it says it has 50 VPCs, then you know that maybe transit WIF is the only way to go. But if it says it has only 8 VPCs and it was a cost-effective, then private WIF or direct connect is an option that you need to consider. Okay, now let's look at the third option, how to connect VPCs across regions. So I think we already discussed this, that VPC direct connect gateway allows you to connect across regions, but you can connect only 10. Transit gateway, you can do multi-region pairing if you want to connect using transit gateway to multiple regions that have your VPC. So now let's take a look at the reference architecture for hybrid connectivity. How do you create a highly available and resilient hybrid architecture? Okay, here's a sample reference architecture that AWS has provided. So it's pretty similar. So you have two customer cages. See, there could be a single point of failure if you only establish connectivity between your on-premise data center to AWS partner network. So AWS provides you with options with multiple AWS partner networks within a region. So you could have two or three partner regions, partner AWS partners who will allow you to establish this kind of direct connectivity. So here you have two direct connect locations. So for redundancy, so once you establish the LAN with these two partners, then you establish connection as we saw in the earlier slide. So you have the AWS cage and the customer cage, which are ongoing separately for redundancy. Then in the first option, what you can do is you can establish connectivity with AWS Direct Connect Gateway using the Transitive, which connects to the Transit Gateway, and then it will connect to multiple VPC using Transit Gateway attachment. So that's for option number one. The second redundant option you could have is again use the AWS Direct Connect with these two different AWS partners, and through the private VIF you establish the connectivity with the VPC using the Direct Connect Gateway. So those are the options you have. The third option you have as a backup is you have the customer data center, then you have the internet, and then you establish connection using the VPN. I think we spoke about how to establish the connection between customer data center and AWS using the VPN. So you use the VPN connection that goes to the transit gateway. So if there is a failure, say of both partner networks or direct connect gateway, you still have the VPN connection which connects to the transit gateway, and then transit gateway connects to multiple VPCs using the transit gateway attachment. So this is how you build, and basically what you need to do is you need to look at each component. Say it was direct connect partner, what if this customer cage fails, what if direct connect gateway fails, what if transit gateway fails. So what are the backup options? Okay, next we are going to look at centralized egress to internet. Why do we need a centralized egress VPC? So first thing is to understand is why do we need a egress VPC? So you can see here you have the egress VPC within the networking account and centralized NAT gateway using transit gateway. So why do we need a dedicated egress VPC? So assume you have 50 VPCs, and in each VPC or half the VPCs you need traffic that needs to be sent out from private subnet to the internet. Then you will need a NAT gateway in each VPC, and NAT gateway you have an hourly charge. So that's the most important thing. Once you have the hourly charge, that means if you have 20 NAT gateways, then you're going to be charged every hour irrespective whether you use it or not. So here you can see you have the spoke account 1, spoke account 2, the multiple VPCs. So you establish some kind of a hub and spoke. So what you do is you route all the traffic from these spoke VPCs or multiple VPCs which need NAT gateway through transit gateway to this networking account, and then this goes to egress VPC, NAT gateway here, and it routes all the traffic via this NAT gateway. So what you will do is you will save a lot of cost for per hour NAT gateways that you might have in multiple VPCs. But there's a catch here that there is going to be some charge from transit gateway in processing that traffic that is coming to egress VPC. So you need to keep that in mind. But mostly if you need a lot of NAT gateways, then you need to centralize that NAT gateway in an egress VPC. Okay, the second one is traffic isolation using transit gateway. So there are two ways of doing it. Either you have some third-party AWS partner appliances, or you can also do it through the network firewall. So this is the diagram. You can see here centralized egress with gateway load balancer and EC2 instance. I had discussed this in detail in one of the previous videos. Basically the concept is very similar, because there's going to be an additional charge for a security appliance if you install it in each VPC. So you have an egress VPC where you route all the traffic, in this case through the gateway load balancer, to this EC2 instance which has an AWS partner security appliance installed, and then it does some traffic inspection on the network packets. Once that's done, it routes the internet traffic back to the VPC. So that's one. The second way you can do it is through AWS Network Firewall. So there are multiple deployment models, and since in this case we are talking about a centralized one, this is the one it is showing here. So AWS Network Firewall is a service introduced by AWS to get over, earlier you had to, as I was just showing you, you had some security plans from third party that you might require for deeper inspection of the network traffic. Now that can be taken care of through this service, AWS Network Firewall. So how do you deploy this? You take a similar approach. You have the traffic coming from multiple VPCs to Transit Gateway, and then there is in one of the subnets you have the Transit Gateway ENI where the traffic is routed. Then that traffic is routed to firewall endpoint for network firewall, which then does the traffic inspection. Then it goes back to this firewall endpoint, and from the firewall endpoint it is sent to Transit Gateway. Just to show you another diagram on what is a typical way to deploy a network firewall. Basically, for if you are not using a centralized model, then what you do is in one subnet you have the network firewall endpoint. So here in this case you can see the traffic is coming from workload through one to this firewall endpoint. Then this is inspected, and then it goes to the internet gateway. Okay, couple of common things we already might know on the VPC peering. So it has certain limitations. You can do the VPC peering across VPCs and regions, but has limitations on the overlapping side, and it also non-transitive. So that's something you should remember. So one last thing I want to discuss in this video is now VPC peering, the longest prefix list in case of overlapping side. So there's a good article by Tutorial Dojo on this. So let me just show you. So here you can see that we have VPC A with CIDR block 172.16.10.0.0/16, and there is this Active Directory service with this subnet CIDR. Then you have the VPC B, which has same, and VPC C both have same VPC CIDR 10.0.0./16, and then they also have the same subnet A and B, and both have again same CIDR blocks 10.0.0/24, 10.0.1.0/24. Now let's assume that there is a traffic that needs to be routed to this IP 10.0.0.66. So where would that traffic go to? Would it go to VPC B or VPC C? Because both are exactly the same subnet and VPC CIDR range, and this falls into both the VPCs. So what longest prefix match says is that it will go to the VPC which has the closest matching route table entry. So you can see here there's a route table entry, and in this case you have a route table entry connecting VPC A subnet to the VPC B subnet 10.0.1.0/24, and for the VPC C you have connectivity between VPC A subnet 172.16.0.0/24 to the VPC C CIDR. So in the VPC B you have the route table entry for the subnet B within which this 10.0.066 falls. But for the VPC C, you have an entry for the entire VPC CIDR block. So which is the closest? It is one with VPC B. So because it's more precise entry than VPC C. So that's how it will decide where to route the traffic. So that's a concept you need to know. I think this is pretty much it. I was thinking of having both the Route 53 as well as hybrid connectivity in this video, but I think it's gone pretty long. So I'll in the next video I'll cover the Route 53. Thank you for watching. Please don't forget to like and subscribe.